All right, let's get going. So welcome everybody to the NCAT from Research to Implementation webinar series. This is our November edition here. And we're going to talk today about asphalt rubber gap graded mixes and some of the things that we've done on the track with that. And then we've got a special guest who's going to tell us about some things that have been done out in the world and so on some highway projects there. So just a few things to remind you, this is every third Thursday we do this. We look forward to seeing you again next month when this rolls around again. Please put your questions in the chat box for me, and I will gather those up and we'll answer those questions when all of the presenters are done today. So today, obviously, we have Buzz Powell, who's a fixture with this webinar series. Buzz has worked, he worked for the Alabama DOT for 12 years and then 2 years in the private sector before becoming NCAT's first test track manager in 1999, and he's now an associate director here at NCAT, and he's also a research professor for Auburn University. I'm going to present today. So again, I'm Travis Walbeck. I'm the training manager and an engineer here at NCAT. I spent my time with West Virginia DOT or their DOH before I came to NCAT here about 3.5 years ago. I did a lot of land development early in my career as well. And I'm licensed in a couple of states. And then our other presenter today, our special guest today, is Mr. Greg Duncan. And so Greg's a senior engineer and a licensed engineer for applied pavement technologies. He's got 30 years of pavement materials experience with construction and roadway maintenance. He's worked at AP Tech, is focused on highway maintenance and pavement preservation and pavement evaluation for both highways and for airfields as well. Prior to joining the AP Tech, Greg was an assistant chief engineer for operations with the Tennessee DOT. During his 22-year career there, he held other positions as the state maintenance engineer, a regional director for Region 4, and the state bituminous engineer. So now Greg lives in Spokane, Washington. He enjoys traveling, skiing, which we got to talk about that, Greg. We got to ski together someday. He also enjoys explaining the Southernisms to the folks that live there in the Pacific Northwest. So given that, I'm going to turn the time over to Buzz, and he's going to kick this off. He'll give it back to me after a while. I'll hand it to Greg, and then Buzz will close us out, and I'll do the Q&A at the end. Buzz, please.
Well, thanks, Travis. Can you hear me okay?
Yes, sir.
All right, good deal. Well, I'm thrilled to be doing this webinar, not just because I'm personally really excited about the potential for asphalt rubber gap graded mixes, but got two good friends here on the webinar with me. Travis and I are current NCAT buddies, and we have a good time promoting implementation together through this webinar series. This week, he's the PI that's going to report on our research that we have in this area. And then Greg Duncan and I have been friends for a really long time. Greg, I think you were here when we built the first track. Am I remembering that right?
That's right, Buzz. I think you actually moved into my office when I vacated the NCAT research building there. So
yeah, that's good. So
we probably stewed in the same office environment there.
That's right. So I'm thrilled to be here with my two good friends here talking about asphalt rubber gap graded mixes. So the way Travis alluded to this, but the way this webinar series works, I usually start out and provide a little bit of background, kind of try to lay the foundation. And then we have our subject matter experts here at NCAT, that's Travis for this week, to come in and do a deeper dive on the research. And then we have a guest come in. Sometimes it's an agency who's done implementation. Sometimes it's a contractor. Sometimes it's a testing lab. And today, Greg Duncan is our guest, and he's got some great experience with this technology while he was with TDOT. And then I come back in at the end and try to pull all of it together with some practical takeaways for everybody. Of course, the basis of the implementation webinar series is all the stuff that we learned at the track that we think can be utilized by agencies in a better way if they can become aware of it. We always talk about track finding sort of as a buffet table, and we spread out the buffet table, and our job is to generate these practical results, and then to help states who choose to do it, help them with implementation, promote and support implementation in any way that we can. And the track's a lot of fun because it's a It's a giant outdoor laboratory. It's ground truth. We can do a lot of testing and a lot of modeling with on the high tech side with capabilities that we have at NCAT and at Auburn University, like a lot of places. But we build roads on the track, short roads on the track that are representative of 5 and 10 mile roads. And what we learn out there tells us how right or how wrong the stuff that we do in the laboratory is, and allows us to validate and calibrate and move technologies forward with confidence. The fun thing for me, as Travis said, I started out with Alabama DOT, was blessed to have a good career with them, and I wrote and enforced specifications, did dispute resolution, and then now I'm working on the other side, and I'm more comply with specifications. So what I find myself doing on any technology we evaluate on the track is kind of put on my agency hat and think, can I write and enforce a specification for this? And at the same time, if I'm a contractor, can I bid and build profitable jobs with this? And that's a fun instinctive perspective to have. And I think that hopefully you'll see some of that come out in the discussion today, especially when we get into take the takeaways there at the end. So just some background on this. We have a long history at the track with what I would refer to as fine blend wet recycled tire rubber binders. We've used them in integrated asphalts, SMAs, and OGSCs. Been doing it for years. When I say wet, I'm not a chemist or a binder expert, but for me, putting on my DOT hat, when a tanker load shows up at my plant and it's been certified and it was blended at the terminal, to me that's a wet binder. But then also what you could classify as a wet binder is if you're at a plant and you have the capability on site to do blending and curing of recycled tire rubber modified binder, then that could be pumped into the plant in the wet state. So I guess for me, wet is if you pump it into the plant and it's in the binder when it's introduced into the drum, then technically I guess that would be a pre-reacted wet recycled tire rubber binder. And we beginning with historically, when we had an SBS shortage in this country, I think that was back in 2008, and agencies wanted to have an alternative for SBS in the event the shortage ever occurred again. That was when we started first doing research with recycled tire rubber binders. But it was the fine stuff, which is kind of a -30 to -40 blend of the recycled tire rubber particles. So as far as gap graded mixes are concerned, with the coarse blend stuff, which is like -16, -20 size, the first time we used that was in the 2012 Green Group experiment, and it was test section S13. And with S13 is shorthand for us, meaning that test section number 13 on the south tangent. And when anybody who's in the webinar, when we talk about the 12 track or the 15 track or the 18 track or whatever, there's a synthesis report at the end of those research cycles that talk about all the different things that we did. So when I give you the section number and the year of construction, then that enables you to go back to ncat.us or paytrack.com and do some research into this and learn more about the technical side of it. But in that study, we wanted to use a base material with a recycled tire rubber focus that had a super high level of fatigue resistance. And that was right after FHWA had done their ALF studies, and they saw insanely high fatigue resistance in a well-designed and well-built ARGG mix. So that's why we picked it for that Green Group study. We picked it again in 2015 when we built what we call the cracking group. It was one of our surfaces in the cracking group. This research was actually sponsored by the Alabama Department of Environmental Management to promote the use of recycled tire rubber in pavements, and it was a perfect fit as a test section in the cracking group. And there we were looking for a surface that had really high cracking resistance, where in the base we were looking for bottom-up cracking prevention. In 2015 we were looking for top-down cracking prevention. Then we used it again in 2018 as an inner layer, so as a binder layer, and it was for the purpose of preventing reflective cracking. When we had cracking below it, to prevent it from reflecting to the surface. So we've used asphalt rubber gap graded mix in all three places in the pavement structure: the bottom, the middle, and the top. And we really have, I think you're going to find as we go through this presentation, that we've had positive experiences with it in every case that we've used it. And it's been the wet technology where we have used it in the past. You know, the coarse particles that was already mixed in and pre-reacted with the binder, but we used warm mix technology every time we ran it. So in terms of like an odor or anything, you had no idea that there was these coarse rubber particles in the mix. Couldn't smell it at the plant, couldn't smell it in the lab, couldn't smell it on the roadway, and nothing but a positive experience with that. Now, you know, fast forward into 2021 at the track in 2022 in Minnesota, and we used a fine grind dry RTR in dense graded asphalts. So where we have this history with the wet stuff already mixed in with the binder, beginning in 2021, now we're using a high-tech feed system and we're blowing it into the plant at the time of production. And so far we've had outstanding experiences with that as well. So that kind of is the background, and I'm going to hand off to Travis now and let him do a deeper dive into research.
That sounds good. Thank you, Buzz. So I'm going to continue on and talk about some of the research and the findings and go into a little more detail about the things that Buzz talked about there. So given that, I want to back up just a little bit and talk about the history of recycled tire rubber or ground tire rubber or crumb rubber. I mean, there's lots of names that we use to talk about the same thing here, which, you know, we do that in asphalt anyway. We do that with the binders. We do that with our compacted specimens from the laboratory. You know, they're pucks in some places, they're pills in other places. Well, ground tire rubber is no different. We have several names for the same thing. So there was research that was done in the 1940s and 50s. A few things were done back then to try to kind of explore things there. Then in the 1960s, Mr. Charles McDonald, he did a bunch of work trying to react the ground tire rubber with the asphalt binders at high temperatures. And he was trying to figure out a way to make that work. Then in the 1970s and 80s, the rubber was used for several different applications, and Arizona was really the leader in a lot of that. In fact, some folks often call it, you know, Arizona rubber asphalt. They use that term quite a bit because Arizona was so predominantly proactive and did so much of this early on in the use of rubber. So in 1991, Congress put some legislation in place that required all the states to use a certain amount of asphalt that had recycled tire rubber in it. And it was kind of an interesting situation because the industry wasn't quite ready. There wasn't the research necessary. There wasn't the facilities necessary to put that kind of rubber in play. And it was kind of a tough situation. Many states struggled to get it to work at all. I know the state I was in West Virginia, we didn't do it at all there. And so a couple years into that legislation, 1995, the legislation, the mandate was lifted. And really it was because the industry wasn't quite ready to do it yet. And so, you know, some of the national research stuff was really in play at that point. Folks were trying to figure out how to use it. Folks were trying to figure out what kind of benefits it would provide, et cetera, at that point. And I really hope, you know, kind of as a sidebar here, I really hope that we learn lessons from that legislation and the way things were done there as we look at other recycled materials and other additives that we can put into our asphalt. I really hope that we remember that we need to make sure that the industry and the infrastructure is ready to implement those kinds of things before we see legislation in place that mandates the use of those types of things. You know, specifically at this point, plastics is something that comes to mind there. So back to the rubber. Now in the 2000s, there's lots of research that's been going on. Buzz alluded to several projects that we've done here at NCAT. There's many states that are using recycled tire rubber in their asphalts, not only for their hot mixes, but also for preservation treatments. There's lots of things that are going on. So as we dive into that, you know, there is kind of an issue here. We don't want to see these kinds of problems again with burning the tires. That's a horrible amount of pollution. And most all the states in the US have been very proactive with getting their stockpiles of used tires under control. We have a phenomenal relationship with Puerto Rico, and they are really struggling right now trying to figure out how they can use their tires because, they're an island and they ship in the new tires, but then the old tires don't really have anywhere to go. And there's warehouses full of them right now down there. So we've been trying to help them implement some of these types of things. But there's about 325 million new tires that are used in the US every year, which means there's got to be used tires going somewhere about that same number again. So as we look at what happens with those tires, this is some information that I gathered from the US Tire Manufacturers Association, and it really depicts, the 2021 numbers. So about 32% of the used tires in the US are ground up. So there's some, other uses that are put together there, all sorts of different things, some fuels. Some of them are still put in landfills, and there's some other civil engineering uses for those tires. But 32% of those used tires, according to this organization, are ground up. Now, interestingly enough, those tires that are ground, that's not all used for asphalt. There's plenty of other things that are used there. They use it for mulch. They use it for, sport surfaces, those rubberized tracks that we see around football fields at high schools, etc. So about 10% of the 32% of tires, about 10% of that is used in asphalt. So I think there's a tremendous amount of growth that can be seen in that industry, as far as if we find the best ways to use this rubber in our asphalts. There is plenty of material out there for us. So here's a graph that kind of shows, again, this information comes from the US Tire Manufacturers Association, and it shows a growth. There's some ups and downs in the number of tires that are being used here, that and this is thousands of tons that we're listed in this bar graph here. But we do see some continuous growth over time of those tires being used there. It's down a little bit in 21 based on what was used in 2019, but I think we have to see an overall trend going upward there. So it is technology that's being used. There are several states that are real leaders in this. I had mentioned Arizona. California is another one that uses a tremendous amount of recycled rubber in their mixes. So as we talk about recycled rubbers, there's a couple different things that I want to make sure we define and we talk about here. So really, the waste tires are processed. They're ground up. They get the metal out. They pull the bead off of the tires themselves there, and then we're going to grind those tires down into the different sizes that are necessary. And Buzz alluded to the minus number 30 mesh or the number 40 mesh is really fine, but there are some uses for some coarser ground rubber as well. There's a couple different kinds of methods. There's a method where they freeze the tires and then break them, and then there's an ambient temperature grinding that happens as well, and it does different things to the particles. The particles look different when they're processed those different ways. So we call it ground tire rubber. We also call it recycled tire rubber. But then Buzz alluded to, there's really two methods that we use. We use a wet method and we use a dry method. So with that wet method, we are going to mix that ground tire rubber with our asphalt binders. And that can either be done at the terminal and then shipped to the plant, or it can be done at the plant and put into a batch tank and allow that time to process there at the facility, and then pump it into the asphalt plant from there. Then the other process is dry, where, like Buzz talked about, we can put it in like where we put the wrap into a plant. Certainly we don't want to put the flame on the rubber, it'll burn the rubber. We can put it in at the wrap collar and add it there. And there's a couple different ways. Buzz talked about using it fine. It can also be done coarse there, and we've seen that used there. When we're using this ground tire rubber as an additive in our asphalt mixtures, we typically look at this being used in either a gap graded mix or an open graded mix. And part of the reason for that is when that rubber reacts with the asphalt binder, it takes some of those light portions of the asphalt binder, and that rubber actually swells. And so when it swells, we need that either gap graded or that open graded mix in order to accommodate the space for that rubber to swell. Now, with these dry processes, there are some manufacturers that are putting together ground tire rubber that is pre-swelled and try to counteract that process, and they're finding tremendous success with that as well. So here's some photographs of just kind of how that process works. Is that, you know, we take the full tires in there, we run it through a grinding process, again, pull the metals out so that we grind it down into smaller pieces, and then it's ground down into the final. This is a really, really fine ground tire rubber that's shown in this photograph here. So again, with that wet process, you know, there is going to be a blending tank of some sort. We're going to react the ground tire rubber with the asphalt binder, and then it needs some sort of a time frame for that process to happen. Again, this can be done either at a terminal or at a plant itself. I visited a wonderful facility up in Massachusetts this last year where they've got several tanks where they hold that binder. And, you know, we test it batch by batch when it's done this way to make sure that we're getting each batch meets the properties that are necessary for our ground tire rubber. So when we mix that, it's going to be mixed at hot temperatures. You know, we're looking at typically about 350 to 400 degrees. And that's where our binders are often anyway, but we need that rubber to melt in. Typical times we see for that reaction is 45 to 60 minutes. You know, it takes an hour or so to make sure that we get that rubber melted and blended into the asphalt binder the way we would like it to be. Again, that, you know, that as we take on those light fractions of the asphalt binder, that swell happens. We'd like that to happen before we get it all mixed in, so that we don't have problems with the asphalt, the rubberized asphalt pushing the aggregate apart once we have our mix together. The, you know, typical ranges that we see in the wet process is between 10 and 22 or so % of the asphalt binder by weight. So again, we're looking at just this is a fraction of the asphalt binder by weight, not the total mix by weight. So it is a relatively small amount, but I'm going to show you later. It's really quite interesting how many tires we can actually put into a ton of asphalt or into a mile of asphalt pavement. You know, it does change the viscosity significantly when we put the rubber into our asphalt binder. This is a really neat graph this is some NCAT data from some construction that was done several years ago out on the test track. And so this is an inline viscosity meter that's on the plant there, and it's measuring the viscosity of the binder as it's pumped from the tanks into the plant itself. So we can see that there's a neat binder phase in this viscosity we're finding at the neat binder. And then they moved on to some polymer modified binder. And so we see that SBS and you know, that's what we see oftentimes is we see that viscosity increase. That's why it's stiff and sticky and more difficult to work with. But then we see a significant jump from there into where the ground tire rubber was put in. And so we can see that jump. And I think this is a really telling graph. I think it's really kind of shows what kind of difference we have when we run from a neat binder into the recycled rubber binders and what we have there as far as the viscosity and how stiff it is to work with. So the other process that we talked about and Buzz mentioned is a dry process. So the material is added in at the wrap collar. Again, we don't want the flame on the rubber. Traditionally, you can use, you know, a 4 to 18 mesh, so that's a much coarser. But there is also a fine process where we're putting that fine material in there. Here in this photograph, we can see that, you know, the material comes in super sacks. It's put into a blower and it runs up. I just barely see the hose. I hope my cursor is showing. You can see the hose that runs from the blower up to the plant itself, and that's the way that the dry process asphalt rubber is put together there. Typically, again, we're using either gap graded or open graded mixes with this process, and we do like to see that the rubber has been pre-treated or pre-swelled, so that we don't have that process happen once we get the material out on the roadway and trying to compact it. So in 2009, there was some work done on the NCAT test track. Missouri sponsored that work, and they were really looking to see if the recycled rubber would provide comparable results to polymer modified binders. So they sponsored 2 sections. One was kind of a control section where they used an SBS modified PG 76-22 binder. The other section they did used chrome rubber, recycled tire rubber there, with 11% by weight of the binder of the 40 mesh rubber. So that was a really fine. Again, this was a wet process, and they put that together. So after 10 million easels, they found that the chrome rubber actually had less rutting, just a little bit less rutting than what the SBS polymer modified binder section had, and really good cracking performance. So most of that cracking performance was in the lab, because we're not finding that these rubber mixes crack under just 10 million easels and 2 years worth of environmental exposure there. But the lab testing really showed that the SBS and the chrome rubber had very comparable cracking results there. So the conclusion that came from that work really was that this chrome rubber modified asphalt mixtures can perform as well as SBS. And as Buzz alluded to, there was the polymer shortage that happened there a few years back, and folks were really looking for solutions, and chrome rubber is definitely one of those solutions. So we move next into the 2012 green group, and this really was a group experiment that was done at the NCAT test track, looking at different kinds of recycled materials. What things can we put into our asphalt mixtures, and how are they going to perform? So there was a control section, there was a high wrap section, then there was another section that had wrap and RAS, and then of course our topic today was using the ground tire rubber in part of these. So this was kind of a full section. There was a base layer, an intermediate layer, and a surface layer, and they all three had the ground tire rubber in them. We found great results there. This is one of those that's kind of impactful to me. In that surface layer, per ton, NCAT was putting 3.5 pounds of recycled rubber. As we look at that, 11-12% of the binder replacement, this is the tonnage that ends up, or the weight that ends up being in there. So that 11 to 12% replacement of binder ended up being about 13 pounds, 11.5 pounds that was in that intermediate layer. And then really this experiment was looking at that bottom cracking and trying to put that fatigue resistant mix on the bottom. So the base was actually almost 30 pounds worth of rubber was included in that binder. Again, this is wet process, so it was pre-blended with the binder, but that was 20% of the binder replacement there. As you do the math and you put that all together, that 29 pounds and in that full section there, we were figuring out that the calculation comes together that using this material in that way was putting about 17,000 pounds of recycled rubber into 1 mile of paving. So there's a lot of tires end up being used that way. So this graph here shows the percentage of the cracked area based with the easels. So we can see that all of the recycled materials outperformed the control section. The GTR and the RAS sections really were very, very comparable there. And I know that the Buzz and the rest of the team in 2012 through 15 construction cycle, they were really excited with the great results and the resistance to cracking that they found from the ground tire rubber at that point. Just to kind of explain further here, the high wrap section debonded, and so it needed to be reconstructed. So a little over 4 million easels, it was reconstructed, and it performed well once it was redone, but there was a debond issue there, which is another soapbox I want to get on, but I'm not going to today, about making sure we've got great tack coats out there on our projects. So, I'm pushing the wrong direction. So as we move on to 2015, the cracking group experiment, another group experiment that a lot of different materials were used in this experiment. They were looking at top-down cracking. So there were several different types of mixes that were used with this one. So when it came to the rubber, there was an asphalt rubber gap graded mix. Again, this was on section S13 that Buzz talked about earlier. There was 1.5 inches of a 12.5 millimeter nominal maximum aggregate size mix that was put down. They used the Marshall mix design, and really at that point, what they did is they took the Arizona specifications and used that as the design process for this surface mix there. So they used Marshall, a 75 blow mix. Again, this was a wet process. It was very interesting, especially with this gap graded, we end up with a much higher binder content. So they looked at 7.4% total binder content in the mix. So that's the regular asphalt binder and the rubber together there. And that's actually QC data. That's not the design. That's what came from the QC data after that. So in that 2015 section, after 10 million easels, there was very little rutting, under 3 millimeters of rutting. The IRI didn't change much, and I think that's very telling to say, the change, what it was laid down as is one thing, but look, what about the change over 2 years and 10 million easels? And so to only have 6 inches per mile change is a really solid material there. So, there was 0% cracking in that lane area. So this mix stood up really, really well to the traffic in the short environmental, only 2 years time frame when it came to this cracking group there. So, balanced mix design is such a big deal, and the most popular cracking test at this point is IDL-CT. So when it came to the testing, part of what was going on with that cracking group is NCAT was looking at validating the different tests, and how can we, let's compare our lab results of these tests back to the field performance of what we see on the test track itself. So here's a kind of a chart that shows all of the different mixes that were used out there. So we had, some control sections with 20% RAP, because that's kind of the national average. There was some other high density mixes there, some mixes with RAS, a higher RAP with a softer binder in there. But we can see the asphalt rubber at the far side there just dramatically outperformed in the IDL-CT test, dramatically outperformed all of the other mixes that were done on that. And then that performance did parlay into 0% cracking on the track after the full cycle had completed there as well. So I do think that that's something that's notable and a real takeaway for folks as we move into the balanced mix design era, that recycled rubber is one of those things that can really help us fight cracking out there. So 2018, as Buzz talked about, the 12 track was really looking at the base. The 15 track really looked at the surface. And then in 2018, Georgia sponsored this section. They were looking at reflective cracking and trying to fight reflective cracking. So some rubber mix was used there as an interlayer. This was a 1/2 inch nominal maximum aggregate size mix. It was gap graded. Again, we want that gap graded so that as that rubber swells and then the reaction happens there, that we don't push the aggregate apart. Again, a high binder content. This one again was at 7.4%. So very similar mix to what we saw with the 2015 mix. So there was 1.5 inches put down, and then 1.5 inches of a dense graded mix. A 9.5 millimeter super paste mix was put on top. Again, we're looking at reflective cracking with this one here. And after 10 million easels, there was no reflective cracking on this particular section here. This is on the north tangent, is where this particular section ended up being. And so here's some pictures during construction. You can see that interlayer down there with 1.5 inches left to go to bring that up to the full surface. Good looking mix out there on the track, and performed quite well over time. Again, after 10 million easels, there was no reflective cracking that came through. So kind of some of the things to kind of summarize that research and the things that have been done here at NCAT, for several cycles. So at least 2009, if not further back, there's been research on the test track with ground tire rubber used there. There's been positive performance. Buzz alluded to that at the beginning, but as I poured through the data and looked at those test track reports that Buzz said that you're welcome to go look at on our website, there was positive performance. All of the work that's been done here at NCAT on the track has been with that wet process that's been documented through the complete cycles there. NCAT looked at the base layers in the 2012 track, surface layers in the 2015 track, and then intermediate layers in the 2018 track. I do feel strongly that there is a need to continue that kind of research and look into some of these other processes and how we can continue to use ground tire rubber to provide good, long-lasting asphalt pavements. So given that, I'm going to turn the time over to Greg, and he can tell us about how the tires have been used in the field.
Great, Travis. You did a fantastic background sharing there of what the history of crumb rubber is and the definitions of the different processes. So I'm going to attempt to share what we did in basically trying to identify how these mixtures were going to perform. I'm having a hard time choosing. Let me back out of this and try it again. All right, the best laid plans, right? Okay, how's that showing up for you?
That looks great, Greg.
Perfect. All right, thanks. So again, I was asked to share with you some experience from our projects that we did in Tennessee, and this occurred back in 1998. I don't think, you know, we don't have the sophisticated test results to show that that NCAT is able to show. So again, we were looking at the construction process. Does this work within our current program? And I apologize, I will use we and our quite frequently throughout this presentation because I still feel a lot of ownership in this process and these programs that I worked in, even though I'm no longer a Tennessee DOT employee. So during this project, I was a field supervisor in our asphalt pavement program. And so when experimental projects arose, they were given to a group of us, me working with the laboratory and sort of being the nomad out on the road to go look at things and try to work out problems and assess. So this is a summary of our projects that we did in 1998. And I will hop into the slides there. I want to say a special thanks to the Tennessee DOT, Heather Hall, the Director of Materials and Tests. I worked with her in order to make sure that I was presenting the views of or the historical view of the Tennessee DOT, and she said go for it. So I want to say thanks for that opportunity. So just to touch on that history, there was IST legislation back in the early 90s that said, DOTs, we want you to use 20% of your pavements have to have some crumb rubber modifier used in them. So I think the rule that was working its way through the process was about 10%. By weight of rubber was sort of the idea of what became a crumb rubber modified mixture. And Tennessee tried to get ready for that. So they looked at what has to be done to make it work. They did some literature review, some quick research, and they tried a couple of projects, I think 3 across the state. They used 10% crumb rubber modifier. I was not a team member at that point. I think it was 80 mesh rubber that was used, and they used a dense graded aggregate structure, again with the wet process, as Travis and Buzz talked about. So blending that asphalt rubber, getting it to swell in the hot mix or the hot liquid supply tank, and then moving into the mixture. And these projects were not successful. The materials made so much VMA. The aggregate structure did not have really high stability, and they saw some rutting. They saw some other problems along those projects. And honestly, just the idea that they were being forced to try something, I think people wanted to find fault in what they were looking at. So they did not deem these projects successful. Later on in 1997, the Rubber Pavements Association offered to come in and do a training class for us and talk about the Arizona experience specifically. And so Tennessee welcomed that, and they did a course touting the advantages of environmentally good processes, and as has been said, producing a crack resistant mix, rut resistant and stable, which we had not seen, and something that could be cost effective. So those were things that were touted, but they said what you need to do is move from that dense graded mix into either an open graded environment or a gap graded mixture. And so what we were told is they were using about a 20% crumb rubber modifier in the wet process and developing these gap and open graded mixtures. And so Arizona is not exactly the environment in Tennessee. So you move from a very arid climate to the Tennessee climate, which is we would think just as hot, but a lot more cloud cover, a lot higher humidity level, so not near the oxidation forces that are working there in Arizona. So we went into this with our eyes wide open. There were two projects chosen in 1998, one in Shelby County, which is in West Tennessee, the other in Dixon County in Western Middle Tennessee. But both of those were on US 70. And so if you look at a map, that's the same road. It's State Route 1, which parallels I-40 through Tennessee. And so doing two projects on US 70, we thought we'd get pretty consistent, comparable pavement loadings, but certainly different mixed materials we would see there. So this is to give you a little bit of background. US 70 was built out of concrete. It was a concrete pavement when it was first constructed and had been overlaid several times with asphalt over the decades. So a pretty thick pavement section, some significant reflection cracks that we saw in the pre-construction review. But these two projects were selected. Again, we did a literature and research review looking at what had been done previously. We developed specifications that very closely mimicked the Arizona process, but were tailored to Tennessee materials. When we let the projects, Lehman Roberts Company and Eubank Asphalt Paving and Sealing were the two low bidders, and both of those companies are very well respected in Tennessee, and both have reputations for being able to take on new or experimental processes and do well with them. So we had what we thought two good prime contractors there. F&F Construction out of Arizona was a subcontractor to both of the pavement primes, and F&F. Mark Belshey was the project manager for F&F, and so they came to Tennessee from Arizona to do the wet process asphalt rubber blending for us. So before we did the design, we took a trip out to Arizona just to get a little bit more familiar with what we were looking at. And so there you can see that arid environment of Arizona. I think this plant was in Tucson. And so very similar equipment to what ended up being used in Tennessee, but certainly different climate characteristics. So we wanted to learn the mechanics. How is that rubber blended? What is the viscosity growth curve? As Travis said, we intended to approve batches of material. So there was a staging plan that we're going to make the asphalt rubber real early in the morning, and then the asphalt plant fires up once the asphalt rubber has been completely digested and the viscosity growth curve has happened. So we learned about that process. From a construction standpoint, we were really interested in how is this all going to come together? How's the crumb rubber going to get supplied? What's going to happen if we have that really hot asphalt, which is 350, 400 degrees and so forth. So trying to identify the give and take there that needs to happen to make it work. We included a quality control plan to monitor that viscosity growth using a Hackey and a Brookfield viscosity measurement devices. We were also going to look at the mixture properties. So we agreed to do the design for the contractors. And so hopefully you can see this. We wanted to point out this is just the design process for the gap graded materials. We also capped these with an open graded material, which you'll see later on. So we wrote a special provision called the 904 CR. So that's particular to Tennessee there. But you can see the job mix formula percentages there. We use close to 80% coarse aggregate in the Lehman Roberts West Tennessee project, and pretty close to 60% coarse aggregate, I would say, in the Dixon County project. So a little different materials approach, targeting the same gradation band, however. And so when we combine that material in the laboratory, what we saw we were very unfamiliar with. And so we were a Marshall mixed design state, and some of you may know that we used effective specific gravity to calculate VMA. And for this project, we used bulk gravity in our design calculations just to observe what was happening and be able to talk apples to apples to other states. And so you see the design curves there, and neither one of them we were able to get to 4% air voids with what we thought was the correct asphalt content. So both designs, and I can tell you, if anybody, Bob Rory was a stalwart for asphalt mix design in Tennessee for several years, and I can recall having a couple of really detailed after hours conversations with he and I both sitting at a table where we ran our bulk specific gravities for all those asphalt pills, and we're just staring at the samples, and we're talking about what does this look like and how is this going to work. And we ended up using an anecdotal mixed design process to set that asphalt content at 8%. I think both of us were trying to hedge our bets a little bit, that we didn't want, we understood the mixed design philosophy, but we did not want to put a mixture out there like we had seen with Superpave, our early Superpave efforts. Some of those mixtures with really high VMAs had come out looking like chili. And so we didn't want to do that with these projects. And so we set both the gap graded mixed designs at 8%. So as Travis said, we used Super Sack mixing techniques. So that crumb rubber hopper goes into the blending tank and gets digested. Our technicians were running quality control, some in the laboratory, some there in the field. We also ran Marshall samples. And what we found is that the construction process wasn't significantly different. There was that lag time that affected the speed of operation. So our West Tennessee project, we had a little bit longer haul to the project and more significant congestion, I would say, not heavier traffic on the roadway, but more congestion getting from the plant to the roadway. So we had a little bit more start and stop kind of delays on the project in West Tennessee. If anybody knows the Eubank asphalt paving and sealing operation, they own their own trucks and they are built for speed. And there was no delay on that project. They typically had several trucks in front of the paver and moved down the road as quickly as possible. We did not specify a rubber tire roller on these mixtures. With that rubber affinity, it was just shared with us that it would be a mess of pickup. So we ended up, you can see these pictures are from 1998. So I apologize, the first generation digital cameras rendering there. But the mixture looks really wet, glistening, This is the gap graded material, so you can see how wet that 8% asphalt mix looks. But this is a typical gap graded mixture, I'm told. So this is what we saw. I mean, nothing out of the ordinary. This is the Middle Tennessee project. So you can see there was a little bit of handwork, which we typically don't like to see there at the joint, but it was possible. The mixture was being placed really warm. We did a review a couple of years after the construction process. And so these are pictures of the open graded mix that was placed on top. You can see the West Tennessee material. This was built out of a crushed gravel. So the brown tint to the pavement as compared to the limestone look there. So this is the West Tennessee material still at the year 2 review. So the joints are becoming evident at 2 years. So again, this project had significant movement underneath. So reflective joints at year 2, we were not necessarily seeing those, but we were feeling them as we drove down that roadway. So a little bit of faulting and but no visible cracks after 2 years. So we thought that was promising. We did have some imperfection, and you see one of my TDOT colleagues there out doing the Winston Gaffron pick test. We had some abrasion at an intersection. You can see the break in the yellow line there is where the intersection is. And so Mike and I are doing improvised traffic control there in the middle of US 70, but we're trying to stay safe at the same time. But that's a good example of the abrasion that we saw. Part of the open graded material was coming disconnected or delaminating from the gap graded material underneath, which you can see there in the wheel paths. But that was the only defect that we saw 2 years later. There's a close-up of that distress appearing. In Middle Tennessee, we saw a little bit different behavior. So this is not in our project, but this is a project that was placed 4 years prior. And so you can see the same thickness of mix. We put a 2-inch binder and an 1.25 inch topping on this roadway 4 years prior. And you can see the reflective cracks coming through that material. I wish I had a picture of the Crumb Rubber project 4 years later, but I don't. I can tell you though, at 2 years of life, we saw absolutely no reflective cracks coming through. We were also evaluating this process because we really like the open graded structure of the surface. And so those were the products that we were looking at. Was this doing its job? Was it keeping the tire water interface safer through this environment? So you can see a pretty heavy rain happening there in Tennessee, but nothing standing on the pavement itself that we were testing. So from I know Buzz is going to wrap up with some practical application takeaways for us. Here's the summary that we took away, that the mixtures were performing well after 2 years, that water was draining away from the surface. So we anticipated a safer roadside environment with higher friction values during rainfall events. And here's my mother and apple pie statement to follow up there, that Crumb Rubber was viewed as providing similar service as other highly modified liquids. However, I'll add this as a caveat. The Tennessee DOT at the time, I can recall in 1998 getting a bid price for a 2-inch layer of PG 76 -22 material bid on I-40, the main interstate that runs through Tennessee, for $17 a ton. That included the aggregate and asphalt material. Again, it's a 76-22. So similar to what we were seeing with the 20% crumb rubber modifier. And so economically, we did not at that time see crumb rubber as playing a sensible solution to fit into the program. So we saw pretty good performance. Again, we were working some kinks out with that open graded friction course. I can tell you the field properties from the gap graded binder, even though we didn't design at 4% air voids, we had good voids in the field when we went to the plant produced material. So we saw good performance. All right, Buzz, I will stop sharing and turn her back over to you. Happy to answer any questions that I can.
Excellent. Good job, Greg. Thank you so much for sharing those experiences. Can y'all see my slide now on takeaways? Yes.
Yes, we see it.
Excellent. I don't have it in my takeaways, but I would add to Greg's comments. In 2012, that was the first time I had ever run mix like this. And you have no idea really what to expect. As he said, you have some anxiety and some apprehension, and I was extremely pleased with the way this mix ran for us in 2012, and I was really excited in 15 and 18 to get it on the track again in different applications, because I really see it as a good alternative for us, at least on certain projects. So my view of the takeaways here, get my pointer to work. We have a proven performance history at the track for underlying well designed and well built asphalt rubber gap graded mixes. They've done extremely well everywhere that we've used them at the track, and I think that's a good thing. And then other states have had really positive experience with them as well. One of the things I'm excited about is there are a lot of states out there now doing relatively gap graded, ultra thin bonded wearing surfaces, and those gradations are actually very similar to the asphalt rubber gap graded mixes. So from a specification point of view, if you're the agency, and from an industry point of view, it's not a huge stretch to go from ultra thin bonded to ARGG. So it's not a brand new thing, necessarily. You're just sort of tweaking the gradation a little bit for the ultra thin, and then adding rubber to it during production. This stuff is highly strain tolerant. So one of the things I advocated for, Greg talked about in TDOT, that was a concrete pavement that had several overlays on it, and we've got a lot of really deteriorated slab concrete pavement in many states. This is a good mix to go directly on top of that, I think, to get you some good years of good performance life and a relatively smooth surface. This stuff is incredibly strain tolerant, not just on the proven on the track, but in the laboratory, like they saw with FHWA at the Alpha facility at Turner Fairbank. This stuff, you can bend it forever, and it just doesn't like to crack because of the rubber particles. Now there's a perception of risk for both industry and agencies with the wet process. And when I say perception of risk, if I'm a contractor, there was some discussion today about the history with chrome rubber, and you can have some buildup in your tanks, some buildup in your AC plumbing system. And so there's some risk aversion, especially on the part of industry with the wet process. It's not just about producing the mix and getting the tonnage down on the job, but it's about what kind of maintenance issues have you created at your plant? What's the maintenance liability at your plant? So there is a perception of risk for that. Well, conversely, there's a reduced perception of reduced risk just from the experience that we're having with the dry options. And these are the materials that are intended to be pre-reacted that we're adding at the plant. So you're not having to run it through your plumbing system, when you do it that way. And I think that creates a lot of options for us in the future. So if you take kind of the ultra thin that's already been being done, and then now you just kind of tweak the gradation, and if you add dry rubber to it at the plant, that's not a huge step to take. There have been improvements in the dry additive feed systems. We always use the high-tech system here at the NCAT pavement test track. We use the same system in Minnesota when we run treated additive mixes up there. And essentially what, if you're a state where you're using the high-tech system, the blue machines to feed cellulose fibers, Travis showed pictures of that, then the same machine now can feed cellulose fibers, or mineral fibers, can feed plastic pellets, or can feed dry rubber particles of all different sizes. Those systems now are very reliable. They've been adapted and continuously improved. And I think improved that reduces our perception of risk when we have more confidence in in that kind of thing. The challenge that agencies have is, in a state like Alabama, that I was raised in Alabama DOT, that we want to receive things at the plant on certification. So we want a tanker load to show up at the plant, and we want a piece of paper that says this stuff grades out as whatever, it has a certain amount of quality. And you don't have any ability to approve of the dry recycled tire rubber additives like that, because you're adding it at the plant. So that means that agencies have to be willing to kind of loosen their grip on the whole certification process, which you're kind of doing anyway if you're mixing and blending at the plant, the way Greg described in his presentation. But you can always do rotational viscometer testing, or GAP DSR testing. There's stuff you can do that give you some confidence that the blended binder is what you want. But with the dry process, you can't do that, and that's the reason why I think this is another example of a technology that pairs well with production BMD testing, because if you evaluate for balanced mix design, the properties in the mix design phase and the control strip phase, you can use that as your tool to monitor production. If you're a contractor, monitor your own quality, or if you're an agency, to validate the contractor's quality, and then to for assurance and acceptance. I think BMD testing is a good fit for using dry additives. Having said all of that, we've kind of bounced back and forth between dry additives and wet additives. We have not done a gap graded dry section on the track. I mentioned in the chat box, we have done dry additive dense graded sections now at the NCAT track and in Minnesota at the Monroe test facility. I would love to do a dry asphalt rubber gap graded section on the 24 track, do it maybe identical to the one that we built in 2015 for the cracking group. Travis did not mention this in his presentation, but that section actually supported 20 million equivalent single axle loadings with 0 distresses. We tried to get funding to do a traffic continuation on it, because I think that section was perpetual, with just 6 inches of plant mix, with the top 1.5 inches being at that really high fatigue resistant asphalt rubber gap graded mix. And I would like to rebuild that section if we can, find a way to get it funded and use the dry process and see, do we have the same outcome? Does it turn out just as good? Is it possible that it's a perpetual pavement? And if it is, then I think we can put these asphalt rubber gap graded mixes in our toolbox with a dry process that anybody can run, just with that simple feed system there at their facility. So that's all I had, guys. I really appreciate Travis and Greg on this presentation. There's our email addresses, and if there's anything any of us can do to help you, we'd be happy to. But again, I would refer you to that ncat.us webpage. Go to the reports and publications, and you can find the synthesis reports for the 12 track, the 15 track, and the 18 track, if you want to learn more about these mixes and how we produce them here at NCAT.
Yeah, for sure. For sure. Guess I'm gonna share back real quick. Here, I want to advertise real quick and make sure that folks, we're a little over, so I'm wanting to make sure that we get the next version of our webinar advertised here. I got to get through this in a hurry. I came up in the wrong spot where I didn't want to be. Here we go. Okay, so December 15th is our next installment of our implementation webinar. There's the QR code. It'll be on December 15th from 10 a.m. So we're going to talk about the cost-effective use of high polymer binders in our asphalt mixtures. That's what we're going to do there. So I do want to double back to some questions here. One question was asked, what was the GTR percentage in the 2015? Buzz answered that it was 20%. So there's a 20% replacement in that 2015 study there. Buzz, have you done any work with life cycle cost assessments with comparing the rubber to the SBS modified binders?
Sorry about that. I was muted. I have not, but in the research that we're doing now, as you know, Travis, Surrey is like, LCAs and EPDs are part of everything that we do, with the additive group experiment in particular, where we use the dry rubber process here and in Minnesota. So we captured all the information that they need to run it through the LCA process. And I'm not an LCA expert, but I did stay at a Holiday Inn Express, so I'm going to offer my opinion on this. Because you do have haul, LCAs and EPDs are very impacted by hauling. And one of the reasons why, the two reasons I think why, or two of the big reasons why RAP helps you on LCAs and EPDs is it's already on the yard, there is no haul, and because it's got a lot of liquid asphalt in it. And with rubber, you got to haul it, and really these rubber particles are like an elastic black sand. So you have, you end up with higher binder contents because you have to coat those particles. If you're dense graded, it's maybe 1/3% more liquid if it's a dense graded mix because you got these, essentially black elastic sand particles. So you got the concern that I have is it might actually hurt us on LCAs and EPDs when it doesn't need, it shouldn't, because this is a very sustainable practice. It's something that we need to be doing. It's just smart sustainability. And my hope is we can find a way to keep it from impacting us in a negative way with LCAs and EPDs. But my concern, as I said, is that the process in the haul and the extra binder might actually do that.
I guess I hope that the longevity that we're seeing and the crack resistance that we're seeing out of these mixes will offset some of those initial costs. That's my hope anyway.
That's a good point. If you look at the whole life of the pavement, I do believe that if we do this right, we're going to get better performance, especially in situations like we've got some badly deteriorated concrete pavement, and we need to maintain serviceability on that road. What's the most cost effective way we can do that? I think this mix is a great choice for that.
Yeah.
And I agree with you, Travis.
Okay, I want to grab just a couple more. We're over quite a bit, and we're usually right on the numbers here. Have either one of you seen anything as far as solubility requirements with the rubber into the binder?
I have not. We've had binders that we've done in the past that were recycled tire rubber binders where we had a separation requirement, where essentially the stuff you can't have phase separation of the asphalt and the rubber particles.
Yeah.
And you can do hybrid binders that have a little bit of polymer, SBS polymer in them, to prevent that separation. But I'm not aware of any kind of solubility or anything like that.
Okay. Greg shaking.
I'm not either. I mean, in practicality, those rubber particles do not dissolve. So there's still a separate phase. So I think if we, it would come out on that sieve as we're trying to run a solubility. So that's why we have to make room for it in the aggregate structure, I think.
That's an important point, Greg, because just for the benefit of our participants, there are a couple of different technologies out there now where essentially you dissolve the rubber. So you're still disposing of the tire rubber, as a mass percentage, but in that case, it's a carbon type product, and it's very different than what we're talking about. What we're talking about are rubber particles in the mix, whether it's dense graded or gap graded or whatever. And there are some technologies out there where you can use tire rubber, but it's completely dissolved, and that's a different thing than what we're talking about today.
Yeah. So, and Buzz, I did see that the question was asked about if we did any permeability tests with the gap graded here, and Buzz mentioned that we did not do permeability tests with that. But there were great densities out there. And if I recall, I think the construction reports that I was reading that looked like densities were in the mid 94% of the rice.
That's right. And with a gap graded mix, we have the expectation that it's going to be somewhere between an open graded and an SMA, maybe, and then the process actually provides for some openness and for some lower densities.
Mm-hmm.
Now, I don't know what Greg saw at TDOT, but here at the track, we've never measured a density that I would consider to be a low density. So my expectation is we'd just be out there measuring near zero permeabilities if we did that with the work that we've done with it.
Right. We didn't run permeability tests either, and the density tests I recall being pretty good. So I think we were shooting for 92% of theoretical.
Okay, that sounds great. All right, I'm going to close it down. We're a little over 10 minutes over. I really appreciate everybody joining our webinar here. I want to thank Buzz and I want to thank Greg. He's a couple time zones away for us, and this was his first task this morning. I welcome you, Buzz. I guess you're in the same time zone as well today. But nonetheless, I want to thank everybody. Please join us again next month as we continue this series. It's something that Buzz and I really enjoy doing. And love sharing this information with you guys of the things that we found here at NCAT with the testing that's been done here. So given that, I'll give Buzz a second and we'll let him sign off.
Thanks, Travis, and thanks, Greg, and thanks to Heather and the TDOT gang for supporting his participation in this. And I just hope everybody has a blessed day. We'll see you next month.
Okay. Thanks, everybody. Bye now.
Thank you all. Pleasure.
Bye.